Welcome all students. Now I will discuss on geography of transport network analysis. Transport geography is a branch of our economic geography, and in our practical part of geography, the network analysis is very important nowadays. So now I start transport network analysis. In my discussion, there are three parts today. First one is prelude or the introductory part, where I have discussed the important issues of transport network analysis for the geographers, as well as it's important for the planners. And part 1, the basic graph theoretical concepts on which the transport network analysis is based. And second part, the final part, is the different measures of network. So first, the introductory part. Basically, the human being needs different types of movement from one place to another, from one geographical place to another geographical place, or the places around the surface of the earth, for their society, for economic livelihood, and for others. Not only that, as we are civilized people, transportation of goods and also nowadays information is very fundamental for the survival of human being. So, movement of people, goods and information have always been fundamental components for survival. And secondly, traditional transportation is one of the tools that helps civilized societies to progress and prosper, and it contributed into each and every facet of our development, because we can't think without the mode of transportation. Hence, transportation plays a major role in the spatial relation between areas and economic development. So, all of us must agree that without transportation, the economic development is impossible. Now, as a geographer or as planner, what are the basic role of geographers? Why we study this transport network analysis, or why we analyzed nowadays the mode of transportation? Geographers have conventionally studied transportation as a part of the broad subject to understand the spatial organization and interaction of an area. Development planning for any region depends heavily on the nature and level of infrastructural facilities. So, transport is the basic and most important component in infrastructure. The first step for evolving any development strategy should assess the existing structure of transport network. We must have ideas that without the transport route, no area becomes accessible nowadays. The task of a planner or a geographer is to assess the prevailing networks and recommend for its improvement. We study the transport network because we have moral responsibility to assess the prevailing network conditions and it is our duty to recommend for its improvement if necessary. So what is the transport network first? The transport network is the layout, geometry of or wave network pattern of transportation, facilities and system. A graph consists of a set of points and set of relationship between pairs of points. A pair of such points may be termed as line, link, connection or relation from the first point to the second one. In geographical applications, the points may be places, towns, road, junction, telephone exchanges and regions. So we often consider these places as points. What are the points? Different places, different towns, etc. etc. But to a mathematician, it consists of a graph as relationship because the mathematician believes in geometry. So to a mathematician, that points, that places, towns, roads, these are actually considered in mathematical terms as lines, edges, arcs and links. Between pairs of points, that is called nodes or vertices. Basically in graph theory, the relationship is analyzed through topology, that is a part of mathematics which is concerned with the position and relationship between points and lines and areas. So my students, the transport network, that is the geometry of space, that is the geometrical shape, geometrical configuration of the space over the surface of the earth. Now the edges are actually the roads, rail lines and points at the places, and the vertices are the important nodal points or towns over the globe. So all the places are basically connected by the graph theory of mathematics. So now I can start the basic graph theoretical concepts. These are the six fundamental basic graph theoretical concept. We should know what is a vertices in mathematical term, what is edge, what is circuits, what is meant by oriented and non-oriented graphs, what do one mean connected and unconnected networks, and the last but not least, planar and non-planar graphs. So in the first part, these fundamental concepts should be discussed. So we can proceed now the vertices. What is vertices? The points which form the basic elements of a graph are commonly known as vertices. So vertices are nothing but the points. So these are vertices. It is also termed as nodes. Why nodes? We geographers often term this as node. But in mathematics or in geometry or in graph theory, these initial points are known as vertices. Edges. Edges are simply nothing but these sides. Actually in geography, sides are the transport route. It may be railway line or high road, etc. etc. Now the circuits. What is a circuit? A circuit is defined as a finite. Finite means that is confined or that is limited. Finite closed path in which the initial node of linkage sequence coincides with the terminal. That means circuit is simply that is the closed one. Very often we term this as closed cycle in division cycle of erosion model. Here it is closed structure. So if we start from here, I can reach there. That is called circuits. Now oriented and non-oriented graphs. Oriented graphs mean that has a orientation. In Bengali it is called Obhimukhikaran. If we start from this circle I can reach in this, or if I start from this, I can complete the round and safely reach in this position. So this is oriented. Oriented means wherever there is a definite direction. This one is non-oriented, means if I start from here, I can go this way or I can move this way. So non-oriented graphs are bidirectional, but this is not. If I start from here, definitely I have to reach there. But if I start from here, after reaching this position, I can choose the path. That is why this is bidirectional or non-oriented graphs. Now, connected and unconnected networks. So network, what is network? This is the actually wave or connected nodes. A network is said to be connected when it is possible to reach a vertex from any other vertex by following the lines of the edges connecting the different vertices. So these all places are connected. If these nodes are some places, these are all connected by, in geographical term, in our case, these are all roots and well connected, or simply all points are connected. That is called connected network. But here we can see that all are separate lines. If these are roads, if this place is A, this place is B, A and B is connected. But if this one is C and D, C, D is not connected with A or B. That is why these are unconnected networks. In practical sense, these are quite impossible. But this type of unconnected networks are found in different isolated places, in hill regions, in forests, in inaccessible positions over the globe. Now, planar and non-planar graphs. This one is called planar graphs. Why? A graph which can be mapped on plane such that no two edges have a point in common. But this one is non-planar. Why? Because if this is a point, this point is common for these edges and these edges. But here, such type of points is not there. So, not any position is crossed. This is called planar, and simply this is called non-planar. Hope you have understood all the basic properties of a graph theory, or the basic elements of a graph theory. So, with this planar and non-planar, the part 1 or first part is completed. Now, the part 2. These are the summary of the part 2, that is different measures of networks. Popular graph theories measures are cyclomatic number, alpha index, beta index, gamma index, pi index, eta index, and theta index. There is another, but I have not mentioned. So, there are 7 basic graph theory measures. These theories are applicable to determine the connectivity, to determine the degree of connectivity, degree of network, etc., for any geographical area. And we geographers very often practice this. So now we can proceed one by one. So first is cyclomatic number. What is that? The cyclomatic number is defined as the count of the number of basic circuits existing in a graph. This number is estimated through the number of nodes, links and subgraphs. So simply, this is the symbol Greek letter mu is the cyclomatic number equal to E plus minus B plus P. So what is B? B means nodes, E means link and P means subgraphs, number of subgraphs. So by applying this formula, we can find out cyclomatic number. Now what is the importance of this cyclomatic number? After calculating a cyclomatic number, what can we conclude? Let me define. The magnitude of the cyclomatic number characterizes the development of the transportation system of a region, have strong association with the level of its social and economic development. Whether any particular geographical area is socially or economically developed, that can be understood by calculating cyclomatic number. We should keep in mind that we cannot able to calculate this if we have any map. If we have not any map supplied to us. So by studying the transport basic things like links, subgraphs, nodes, edges, vertices, we cannot able to calculate cyclomatic number. So if the value of cyclomatic number is more, that means the area is socially and economically more developed. Okay. I am giving one calculation sheet now. This one is a cyclomatic number calculation sheet. 4 planes are there. So here vertices is equal to 4. What are the vertices? Vertices are nothing but the terminal points. So A and B, C and D. 4 vertices. E is equal to 2 edges and P is equal to 2 because there are 2 subgraphs. These are not connected. So number of subgraph 2. If we apply this formula, result will be 0. That means the place is socio-economically very backward. Why? Because the places are not connected by transport network. Simple to understand. Now, here B is 4, E is 3, 1, 2, 3 and subgraph is 0. Why? There is no division. That is why. Sorry, subgraph is 1. There is no division. Single one is there. That is why cyclomatic number is 0. Here is also cyclomatic number 0 because this A and D are not connected. This one, the cyclomatic number is 2. These places are well connected. This is also 2, well connected. Okay. Next one is alpha index. Alpha index is the ratio between number of actual observed circuits and the maximum number of circuits possible in a given network. Actually, this actual or observed circuits is nothing but the cyclomatic number. So, it may be called, it is the ratio between the cyclomatic number and the maximal possible value of the cyclomatic number. What could be the maximum number of cyclomatic number of a graph? How much? The highest number may be 2b minus 5. This formula is derived by the geographers or planners. So, this is nothing but the ratio between the cyclomatic number and the highest number of cyclomatic number that could be occurred. What is the significance? The value of the alpha index vary from 0 to 1. So, lowest value will be 0 and the highest will be 1. If we turn these into percentage, it will be 0 and 100 as well as lowest and highest. A value of 1 would refer to maximum connected network. So the alpha index calculates the connectivity. If the value is 1 or 100%, it is the maximum connected network. And if it is 0 or lower or towards 0, the value is towards 0, the connectivity is minimum. Now, these are the calculation sheet. Here AB, BC, CD, D. So age is equal to 1, 2, 3, 4. V is equal to 5 points. Alpha index is equal to 0 because the places are not connected, well connected. Here the alpha index is 0.4. Here the alpha index is 0.6 because the places are connected. So these places, this graph is most connected. Now beta index. The beta index is the simplest form of the three measures. Alpha, among the measures of alpha, beta and gamma, these are three basic measurements actually. The rest are not basic actually. All others are very critical measurements, but alpha, beta and gamma, these are primary measurements. Among these three, beta is the simplest one. It is the ratio of edges and vertices. It is very simple. It is the ratio between edges and vertices. What is the significance? The beta index takes a value between 0 and 1, depending on the nature of the disconnected graphs. In non-planar graphs, the ranges of beta index is from 0 to 3. So, for the planar graphs, it will be 0 to 1, but it can be maximum 0 to 3 in non-planar graphs. Beta values exceeds 1 for a complicated network structure having more than one circuits. So this is the calculation sheet for beta index. Here beta value is 0.8. Here it is 1.2. Here it is 1.4. So we can easily understand this place is more developed rather than other two. Now gamma index. The gamma index is a measure of connectivity that constitutes the ratio between the observed number of edges and vertices of a given transportation network. Simply, it is the ratio between the observed number of edges to the maximum number of edges in a planar graph. For a network considered as a non-planar graph, the gamma index has been defined as. So this is the formula. Gamma is equal to E by 3 into V minus 2. If the index is 0 to 1, or in case of percentage 0 to 100, a value of 100% will be described to a completely connected network. This is the calculation sheet for gamma index or gamma value. Here E is equal to 4, V is equal to 5, so gamma is equal to 4 by 3 into 5 minus 2 is equal to 0.44. Here it is 0.67, here it is 0.78. Again that place is more connected than the rest of the two. Now pi index. The pi index has been developed to examine the relationship between a transportation network as a whole and specific edges of the network. It is called pi index for its logical similarity. So in geometry, pi is nothing but the ratio of perimeter and the radius. So simply pi is 3.1415. It expresses the relationship between the diameter and the circumference of area, where C is the total mileage of a given transport network and D is equal to diameter. The length of the shortest path between the most distanced nodes of a graph is the diameter. So in this transport network analysis, diameter is something different from the diameter of a circle, because the transportation network not follow any circular pattern at all. So length of the shortest path between the most distanced nodes of a graph is the diameter. The pi index give a numerical value be greater than or equal to 1. So it may be more or less than 1. Higher numerical value will be described to more complicated transportation network, and it indicates higher degree of development of the network also. Now Eta. The Eta index have been designed to capture the structural relationship between the transport network as a whole and its route as individual elements of that network. The Eta index is the average measurement of edge length. Simply, it is the ratio between total network length and the observed number of edges. So it is nothing but the average edge length. So how can we calculate the average length, total network length in kilometer? By the observed number of edges. So a large value of the Eta indicates either a sparsely populated area or may correspond to lack of connections with the en route nodes, and thus represents the disjunction associated with the space intervening between 2 points on a network. Actually, Eta index calculate the average edge length per edges. So it determines what are the ratio of points, what are the ratio of places in mileage distance. So these are the worksheet A, B and BC. So there are 3 places A, B and C, and the distance is total 100 plus 80 kilometer, but path is 2, that is why the index is 90 kilometer. Here A, B, C, T. So in between this 100 kilometer there is another point now. So that means within this route there is one more town or there is one more settlement unit. So obviously the route is broken here. That is why the distance is also splitted as 50 kilometer and 60 kilometer. Then CD is 100 kilometer. So total is 210 kilometer by 3, because 3 now as this AC is splitted. So here it is considered as AB one separate route and BC another route. So 3 routes, 1, 2, 3. That is why divided by 3 is equal to 70 kilometer. So same length, its value is lower than this. Again this, it is 40 kilometer and then it is 48.6 kilometer. So these 2 places are indicating lower value of Eta, but the places are well developed or maximum number of points are there. Now the last one is theta index. The theta index is a modified form of Eta index and may be represented as follows: T by V. See, T is equal to total traffic flow or the total volume of freight is carried, and V is equal to observed number of vertices. One may also express the totality of transportation networks in terms of the total route length as before. In such case, the theta index is written as this. So there are alternative thinking also, where M is equal to total route measurements and V is equal to observed number of vertices. The theta index offers information on the length, structure and also on the degree of connectivity of the network simultaneously. So this is the importance of theta index. So this one is calculation sheet of theta index. Here total route measurement is 180 km. Total number of vertices 3. That is why theta is equal to 60 km. But here A, B, C and D. Total route measures 220 km. Total number of vertices 4. That is why it is 55 km per vertices. Here it is the total number of transportation carried is 150 km. This is alternative thinking from A to C. That is why it will be 5 raised to 1. So theta index is nothing but the modified form of eta index. Hope all of you have understood properly. Thank you.